Alright, today we're going to talk about probabilities. So far we've been talking about how to figure out how many ways something can occur. That's an important skill in probability because what we're going to do in probability is think about the number of ways that one thing can happen divided by the number of ways that anything could happen. Okay? So it's the outcomes that fit what we want divided by how many outcomes are there actually. Okay? A probability is a number between 0 and 1. Many people report a probability as a percent, which isn't totally accurate. We can take that decimal and turn it into a percent, but technically a probability is a number between 0 and 1, reported as a decimal or a fraction. A probability of 0 means there is no possible way that event can occur. It is just impossible. So, for example, in rolling a die, what is the probability that I get an 8? 0. I can't, right? I can't. It's not possible.
What if it's a 10-sided die?
You got a point there. So a probability of 0 means impossible. A probability of 1 means it has to happen. Okay? And then between that, we end up with all of our middle probabilities. If we get a probability of a half, that is equally likely and unlikely to happen. Okay? You can use decimals or you can use fractions. So for our first example, we're looking at rolling a 6-sided die. Sides are numbered 1 through 6, and we have 3 different questions in here. So first, what is the probability of rolling a 4? So we do, how many ways can we roll a 4? Well, there's only the one side that has a 4 on it. Out of how many things could happen in rolling that die, we could get 6 different results. So our probability is 1/6, and you can leave it as a fraction, or you could type it into a calculator and turn it into a decimal if you'd like. For B, rolling an odd number. How many odd numbered sides are there on a die? 3. 1, 3, and 5 are odd numbers, so there are 3 odd numbered sides out of the 6 sides. If you report your answer as a fraction, it should be a reduced fraction, or you can report it as a decimal. For C, the probability of rolling a number smaller than 7. How many numbers smaller than 7 are there on a die? 6 of them, and there were only 6 sides, so we get a probability of 1 for that. That means it has to happen. You have to get something smaller than 7. For the second example, we're talking about a spinner, which has 8 sections, each of equal size. What is the probability of spinning a 6? There's one section with a 6 on it out of 8 sections on the spin. For B, what is the probability of spinning a number greater than 5? How many numbers greater than 5 would there be? 3, 6, 7, and 8. Watch out for the way that questions are phrased. We could say greater than, or we could say greater than or equal to, which would give different answers, right? Because equal to would allow the 5 also. Here we're just allowing bigger than 5, so 6, 7, and 8. 3 possibilities meet our need out of 8 possibilities.
Are we going to be working with like problems where the sectors aren't equal size?
No.
No.
What we've been doing here is called theoretical probability. Theoretical probability is what should happen in a long run. Okay? So thinking about flipping a coin. In the long run, we should have equal chance to get heads and tails, right? Each individual flip is a 50-50 heads or tails.
Yeah.
If I flip a coin 1,000 times, it will probably be close to half and half, but not necessarily perfect. If I flip a coin only 10 times, it would not be a cause for concern to get 8 heads. Okay? So probability is something that occurs in a long run. Okay? In a short term, events are random. The coin does not care that it just landed on heads. It could just as soon land on heads again. Okay? A long time ago when I taught probability, I actually assigned students to flip a coin 100 times and write down the results, and I could tell who cheated. Because
Wow.
students who didn't want to actually take the time to flip the coin and just wanted to write down heads and tails would have very balanced answers. So their answers would be something like heads, tails, heads, tails, tails. Very symmetrical, so that in the end, they would end up having about 51 and 49. It's actually quite unlikely that it would be that balanced. It would be more common to end up with getting a streak of maybe 8 or 9 of something in a row. Okay? And students who cheated, I never saw those streaks in there. Okay? So I could tell who actually took the time to flip the coin and who didn't.
Have a phone app.
Yep, there's a phone app. There's also on a graphing calculator on a TI-84. There's a coin flipper dice roll app as well. So theoretical probability is what should happen in the long run. So in theory, half of coin flips should be heads and half of them should be tails. In practice, that's not necessarily going to be true. And that's what's called experimental probability, when we actually do it and see what happens. Okay? Theory should be close to what we see happen, but it's not going to be perfect because we don't live in a perfectly symmetrical world. So experimental probability is found by either trying coin flips or rolling dice or by taking surveys of data. So this question refers to a survey, which you don't have the data for. So this is the survey data it refers to. It says this survey was taken in 1998 and asked people, internet users, for their ages. The first part says, what is the probability that the person is at most 20 years old? So to find a probability, we're looking for the number that meets our requirement divided by the total. So how many people meet our requirement here? Okay, so at most 20 years old would be under 21, so that'd be 1636. Divided by what? What would I do to figure out what to divide this by?
Add
Add up all of the people who were surveyed. So 1636 plus 6617 plus 3693 plus 491 plus 6 gives 12,443 people were surveyed. Okay. This fraction means nothing to me in terms of how likely this actually is. So when you're working with smaller fractions like 1/6 or something like that, it's fine if you just want to leave them in a fraction. When we're working with numbers that we really don't have any perception of, it is best to turn this into a decimal to see how likely this event actually is. So 1636 divided by 12,443 gives us 0.13. Okay. As a probability, it should stay as a decimal. We tend to report a lot of probabilities as percent, so we could say it's about a 13% chance. But we tend to leave them in probability. We should leave them as a decimal. Part B of this question said, what is the probability that they are at least 41? So then who meets our criteria?
The first two.
The last three.
At least 41 would be 41 or older. So we're going for our last three sections here. So we would add up those three values. 3693, 491, and 6 give a total of 4,190 people in those groups. Divide by the same total. Gives about 0.34, or about a third of them. Okay, so about a third of the internet users were at least 41 years old. This survey was taken in 1998. The data now would be quite different. In 1998, when I was in high school, I very rarely used the internet for anything because there just wasn't much to do on it. In 1998, it was mostly for business purposes, so that's why it's older people here using it and not younger people. The data would be really different now.
On 21. Still tiny. A little bit bigger.
Be a lot bigger.
The next question asks about some math enrollment. It says at a particular school, students in 9th grade are required to enroll in a math class, and here's the data of which math class they enrolled in. So the first part of this question says, what is the probability that somebody is enrolled in consumer math? So the probability we're enrolled in consumer math, we would say, well, how many are enrolled in consumer math? 36. Out of how many students are there in this particular grade? And we would need to add up all of the options. 87 plus 36 plus 69 plus 51 gives us a 9th grade class of 243 students. Okay. You need to add up all of the groups for the denominator. We're looking at how many meet our criteria out of everybody. Again, this fraction doesn't have very much meaning to me in terms of how likely this is, so turning it into a decimal makes it a little bit better to be able to see the comparison. So we get about 0.15, or about 15% of these 9th grade students enrolled in consumer math. Part B says, what is the probability that they're enrolled in Algebra 1 or Intro to Algebra? So some kind of an algebra course. So, or as a probability word yesterday we talked about meaning add. So we're going to say our algebra and Intro to Math students together give 138 out of the entire class of 243. Which gives about 0.57, so more than half of the students were enrolled in some sort of algebra. Questions? Since this is geometry, one more topic to discuss is what is called geometric probability. Geometric probabilities are where we're going to look at ratios. Ratio means fraction of areas. Okay, typically on these we're going to be thinking about some sort of a dartboard type situation. So number 5 says you throw a dart at the board, you are equally likely to hit anywhere on the board. You will definitely hit the board, but you may hit anywhere on this board. Are you more likely to get 10 points or 0 points? Now, if this board is well designed, a random throw should not be able to earn you a lot of points, right? So if this board is well designed, we should be more likely to get 0 points than 10 points. But we want to make sure that actually happens. So the dartboard it refers to looks like this. So what we want to do first is find the probability of getting 0 points. The probability of getting 0 points means we need to know what area of this board has 0 points. The 0 point area is the point that's within the square but outside of the circles. So to find that area, we need to find the area of the square and subtract from it the biggest circle. And that would give us those little kind of triangular sections on the outside, but they're not really triangular.
But like what? How do we know that the circle in the square is?
Good question. So how do we know the length of the square? This is the only information we're given in this picture. So how could we know? Because for area of a square, I need to do base times height.
It's 36 meters squared.
I haven't heard the right answer yet.
It's
324.
18. If each of these sections are 3,
Oh,
to get all the way across, I
Oh,
need
each
3,
section.
6, 9, and then since this is a circle, it should be the same on the other side. 12, 15, 18 will take me all the way across that square. And since this is a square, both of the sides are the same. So the area of the square is 18 squared, or 18 times 18. Then we need to remember area formulas for a circle. Area of a circle is pi r squared. What is the radius of the biggest circle here so that we're taking away everything except for the 0 space? 9. Okay? Each of those sections is 3, so to get from the center all the way out to the edge of the biggest circle, we need 3, 6, 9. Type this into your calculator, including the pi. Okay? So 18 squared minus pi times 9 squared. You can just use 3.14, or you can use your pi button. It won't make that big of a difference. And I get 69.53. That is the area of the zero space. To find the probability of the zero space, we need to take the zero space divided by the total space. What would the total space be?
18 times 18.
The square, 18 times 18. So we're going to do our answer that we got divided by 18 squared. If you're doing 18 times 18, you need to put parentheses around it. If you're just doing 18 squared, it will be fine without. But I get 0.215, or just 0.21 is fine. So about a 20% chance of getting no points. So the question said, how does getting 0 points compare to getting 10 points? So now we want to find our probability of getting 10 points. The area of the 10-point region is just the bullseye. So that would be pi. What's the radius of that? 3 squared. And again, type that into the calculator with the pi. So 9 times pi is 28.27. So our probability of getting 10 points is our 10-point area divided by our total area, which is 0.087. So only about 8-9% chance of hitting the bullseye. So this board is well defined then. You should be more likely to get 0 points than 10 points on a random throw. We have one more example of this type of problem, but are there questions on this one?
So in an assignment, if it asked for that, for the answer, would you give the probability of
Yeah, give the two probabilities. Yep.
So the answer would be 0.215 and
0.087. Yep. The second question on this uses this board and says, what is the probability of hitting the shaded region? So here we're looking for the probability of the shaded region. So to do that, we need to be able to find our area of that shaded region, which is the area of the rectangle minus the circles. To find the area of the rectangle, we need a length times width or base times height. I see one measurement of 4 there, but we are not told about the other side. We should be able to find it, though, with only this given information. So what will that be?
Would the radius be 2?
Yes.
Okay.
8. Okay. So if it takes 4 to get across the circle in one direction, because it's a circle, it should take 4 to get across the circle in any direction. Okay. So we have a length of 8 going across the rectangle then. So our rectangle has an area of 4 times 8. We want to subtract from that our circles. There are 2 circles, so we're going to do 2 times pi. The radius will be 2. If it took us 4 to get all the way across, we're going to have a radius of 2. And type this into your calculator, once again typing in the pi. And I get 6.87. That is the area of the shaded region. If I want the probability of the shaded region, I need to take my shaded area and divide that by the total area, which would be what? 4 times 8. make sure you put parentheses around that 4 times 8 when you type it in the calculator, or just do it and then divide by that number. But if you don't put parentheses around that, your calculator is going to divide by 4 and multiply by 8, which is not what we want to do.
Okay, but you take the 6.7 and then you put it over what?
Over the total area of the rectangle.
Okay.
So 0.21, 4 or 5 about. So we have a 22% chance of hitting outside of the targets here.
How many decimals would you recommend we go
2 or
out?
3. Okay?
Same answer.
All right. Yeah, it turned out to be the same answer as the last one. That's pretty coincidental. For your assignment,
We know it now.
for your assignment, a couple of the questions refer to some colors. I think you could probably figure it out even without knowing the colors, but your copy is in black and white. So for number 30, it says the red center. That is the center, the smallest circle. And for number 33, it says the 4 rings, I can't spell rings, 4 rings, or center. So that would be the whole circle space.
4 rings left.
Or the red center, it says in the question. It says the 4 rings or the red center. That's talking about the entire circular space there on that one. Okay? So I don't think the colors were really too necessary, but just to make sure you know what those pictures are talking about now.